Hi everyone. This video is on complex fractions. There are two types of complex fractions to consider. The first type will be a complex fraction where the numerator has one fraction and the denominator has one fraction. So only one fraction on the top and one fraction on the bottom. That's one type of complex fraction. Here are some examples of those. The second type will be a complex fraction where the numerator and or the denominator have more than one fraction. So there's usually a plus or a minus sign between two fractions on the top and the bottom, or the top or the bottom. There's got to be multiple fractions in either the top or the bottom, or both. Okay, that's a little complex. That's why they call them complex fractions, but it won't be that bad. Okay. So we'll discuss the first type at this point. So simplifying complex fraction of the first type, again, that's only where there's one fraction in the numerator and one fraction in the denominator. There are two methods. We're going to show one method, okay? I think it'll be the easiest. But there's different ways of doing problems. You probably have figured that out already. There's often multiple ways of solving a problem or working a problem out. So we're just trying to show one way here. Okay, so here are our steps. Step 1. Rewrite the complex fraction as a division problem using the division symbol. So we're going to rewrite it as division. And then we're going to change the division to a multiplication problem. And then we're going to perform the operation as shown in previous lessons. So you might have heard the phrase keep, change, change, or keep, change, flip. That's what we're going to do. Okay, here's our first problem. 2/3 over 1/2. So we're going to rewrite this as a division problem. The top fraction goes first. Then we're going to do a division symbol between the two fractions. And then the second fraction is left. The second. Okay. So 2/3 divided by 1/2. The top number divided by the bottom number. Change to multiplication. So keep, change, flip. We should try to reduce. Nothing will reduce here. So multiply straight across. And that'll give us 4/3. This problem was an arithmetic problem. There's no variables. This is an algebra class, so we need to add some algebra to it. Add some letters. Some factoring. Yeah. Okay, so it's the same procedure. It's the top fraction divided by the bottom fraction. So rewrite it as a division problem. The top fraction is first, then we put a division symbol, and then the bottom fraction is second. And now we turn it into a multiplication problem. Keep, change, flip. Okay, we'll try to reduce. We can reduce the 4 and the 8. Yes, 4 goes into 4 one time and 4 goes into 8 two times. You could reduce the x's here, or you could wait and put it in a single fraction and then reduce. The x's, there's one more x on top because it was an x squared on top and only one x on the bottom. So there's one more x left on top. And the y squared, there were no y's on the top, so it's just the y squared on the bottom. We have a 9 left on top, and then a 2 times 5 on the bottom. So our answer is 9x over 10y squared. Okay, here's our next problem. This is very similar to the section that you did on dividing rational expressions. It might have been multiplying and dividing rational expressions. It's the same problem that you've done before. It's just that it's written as a complex fraction. So all you need to do is rewrite it as a division problem. And then it's the same problem that you've done before. Okay, so step 1, rewrite as a division problem. So it's a top fraction divided by the bottom fraction. Change to multiplication. So keep, change, flip. So the first fraction you keep the same, change the division to multiplication, and then flip the second equation. Now we're going to reduce. So you have done this before. You're going to have to factor the trinomial and the binomial. You might want to pause the video and then factor those two. So the bottom left, let's see, x squared plus 3x minus 28. What are the factors of 28 that subtract to be 3? Right, 7 and 4. Positive 7, negative 4. Okay, then the top right, x squared minus 49. That is the difference of two squares. 7 times 7 is 49, so it's going to be x plus 7 times x minus 7. So now rewrite those in the problem, replacing the binomial and the trinomial. And now we can do some canceling. The x plus 7's cancel. Anything else? Yeah, how about the 12 and the 20? 4 goes into 12 3 times. 4 goes into 25 times. We could reduce the x's here now. We have 4 on top, 1 on the bottom, so that would give you x to the third on top. And the y's, there's 2 on top, 4 on the bottom, so that would give you 2 left on the bottom. Or you could put it as a single fraction, put together, and then reduce. So we have 3 x to the fourth y squared, x to the x minus 7. And then on the bottom, 5x y to the fourth, x minus 4. And now at this point, we could simplify the x's and the y's. There's 3 more x's on top and 2 more y's on the bottom. You do not have to distribute the monomials in front, the 3x to the third and the 5y squared. It's best to leave it like that. You can. The answers are usually given to us in factored form in the back of the textbook or on a homework assignment, so there's no need to distribute. Okay, now we'll talk about the second type. Again, there are multiple methods of doing these problems, so I'm only going to show one method here. I think it's the easiest, but there are other methods, and we'll talk about that. Simplifying complex fractions with more than one fraction in the numerator and or denominator. Number one, find the LCD of all the fractions in the complex fraction. So we're going to look at all the fractions and look at all the denominators and find the LCD for those denominators in the top and the bottom. And then we're going to multiply each fraction by the LCD. By doing this, it enables us to divide out each of the denominators. So we're going to multiply each term by the LCD, and that's going to wipe out the fractions. We're still going to have a fraction overall, but it won't be a complex fraction. Okay, so 2 steps. Let's do it. Okay, here's an arithmetic problem. There's no x's. So we'll start with that, and then we'll build up to an algebra problem. LCD. So what is the LCD of 3, 2, 4, and 6? So we're looking at all the denominators. Right, it's 12. So that's our first step. We had to find the LCD, and then we're going to multiply each one of those fractions by 12. So just put a 12 next to each numerator of each fraction. Okay, now we're going to reduce. We're going to divide out the denominators. So that 3 goes into 12. How many times does 3 go into 12? It goes into there 4 times. How about the 2 in 12? How many times does 2 go into 12? 6 times. Now looking at the bottom, how many times does 4 go into 12? 3 times. And how many times does 6 go into 12? Twice. So we reduce all those. So again, I cross out the 3 and the 4 and just put a 4 where the 12 is. All the bottom numbers will cancel. We're only left with numbers on the top. 2 goes into 12 6 times, 4 goes into 12 3 times, and 6 goes into 12 2 times. Now we're going to multiply what's left. On the top, it's 4 times 2, so that's going to give us 8, plus, and then 1 times 6, which is 6. So on the top, we're going to get 8 plus 6. On the bottom, it's going to be 3 times 3, which is 9, plus 5 times 2, which is 10. Okay, 8 plus 6 on top, 9 plus 10 on the bottom. And then simplify that, 14 over 19. The other way of doing this problem is by actually adding the fractions on top, 2/3 plus 1/2, and adding the fractions on the bottom, 3/4 plus 5/6. You therefore have only one fraction on top and one fraction on the bottom. Then you could do the division of one fraction divided by another fraction, type 1. Okay, here's our next problem, an algebra problem. Step 1, find the LCD. So we're going to look at all the denominators, and we're going to take the LCD of all the denominators. So looking at the A's, what's the most number of A's in one fraction? Only 1. But how about the B's? What's the most number of B's in one of the denominators? Or the highest exponent that you see for the letter B? That would be 2. So our LCD is AB squared. Now we're going to multiply each fraction by the LCD. So you're just going to write that AB squared next to each numerator. Now we're going to simplify. So in the first fraction, an a cancels with an a on top, and a b cancels with one of the b's on top. That's in the first fraction. On the second one, the b squares cancel, but not the a on top. On the bottom, an a will cancel with the a next to it on top, but the b squared does not cancel. And on the bottom of the second fraction, we have a b, so we'll cancel that with the b on top, and that'll leave us still with another b, and the a will not cancel. So what we'll get is 4b minus 3a, and on the bottom, b squared plus 3ab. I didn't show any of the canceling, so that was kind of messy, so it was more of a mental problem how we did that. The next one will show the canceling. It might be easier when we do the canceling. It's totally up to you if you need to show that or want to show that. Okay, this one has 4 fractions. To find the LCD, all the denominators must be factored first. So that's our first step. That bottom fraction on the right, that needs to be factored. It's a difference of 2 squares, x squared minus y squared, so that what does that factor to? Yes, it factors to x plus y, x minus y. Okay, now our LCD is x plus y and x minus y. The most x plus y's would be 1, and the most x minus y's is also 1 in any denominator. So that will take care of each denominator. When we multiply each fraction by the LCD, there should be nothing left in any of the denominators. Okay, so let's multiply each of them by x plus y, x minus y. Okay, so on the left in the top, what's going to cancel? Right, the x minus y's. How about on the right? What's going to cancel? Yes, the x plus y's. Okay, now moving to the denominator. On the left, what's going to cancel? Right, the x plus y's. And on the right, what's going to cancel? Well, both of them, the x plus y's and the x minus y's. Now, what do we have left on top? Well, we're going to have to do some distributing. We have a 2 times x plus y. We have a 3 times x minus y. On the bottom, we have a 5 times x minus y. And the negative 1 times nothing, just negative 1. So it's 2x plus 2y plus 3x minus 3y. On the bottom, 5x minus 5y minus 1. We could add some like terms on the top. On the top, the 2x and 3x will give you 5x. And then the y's, 2y and negative 3y will give you negative y. So there's your answer. Okay, we're almost done. 2 more problems. Find the LCD. Well, we look at all our denominators, and there's only one denominator. Sorry, there's only one letter for the denominator, and that's x. And then you're going to take the highest degree of that variable. So what is the LCD for this fraction, this complex fraction? It'll be x squared. We just take the highest degree term that you see. So the LCD is x squared. Some people will make a mistake and add the x's and they'll put x to the third. What that does is it creates more work for you, more factoring. Okay, so x squared, so everybody gets an x squared. So x squared times a 1, x squared times a 7 over x squared times a 12 over x squared. On the bottom, x squared times a 1, and x squared times a 16 over x squared. Okay, now we can reduce. Let's see, in that middle fraction, one of the x's cancels with one of the x's on top, and so we're just going to be left with an x. So I tried to show that by just canceling out the number 2 on top. On the next fraction, the whole x squared cancels, and same thing on the bottom, the x squared cancels. So now what we're left with is a fraction, x squared minus 7x plus 12 on top, and x squared minus 16. That should look familiar. Now we need to factor both the numerator and denominator. You have to simplify the rational expression. More factoring. So how about the top? 12, there's 1 times 12, 2 times 6, and 3 times 4. What's the pair that will add to give you negative 7? Right, 3 and 12, both negative. And on the bottom, it's a difference of 2 squares. It's x minus 4 times x plus 4. Okay, I didn't really show any of the work there. You might want to pause it and work it out for yourself. Then we could cancel. The x minus 4's will cancel. And there's our answer. X minus 3 over x plus 4. So do you see the idea here? Find the LCD, multiply each term by the LCD, simplify it, and then we might need to factor again, and then simplify the fraction again. Okay, last example. What is our LCD? Our LCD is only x minus 5. Now you may notice the integers 2 and 1. The denominator of 2 would be 1, and the denominator of 1 would be 1. So even if we use 1 as part of the LCD, well, 1 times anything is that anything. So the only denominator that we need to be concerned with is the x minus 5. It occurs on the left fraction on the top and on the right fraction on the bottom. So our LCD is x minus 5. So now we're going to multiply each fraction by x minus 5. Now don't forget, even the 2 gets multiplied by x minus 5 because that is a fraction. It's 2 over 1. Same thing as the 1 on the bottom. It's a 1 over 1. So those are fractions. Okay, so now we can cancel the x minus 5's. And then distribute the negative 2 and the 1 on the bottom. So on the top, just the 3 is left. And then distribute the negative 2. There's a negative in front, so don't forget the negative. So negative 2 times x is negative 2x. And negative 2 times negative 5 is positive 10. So that's the top. And on the bottom, 1 times x minus 5 is just x minus 5. And then don't forget to bring down the minus 4 because the x minus 5's cancel. So now we could add some like terms. And that will give you negative 2x plus 13 all over x minus 9. Wasn't too bad, right? All right, I'll see you here for the next one.